Okay, here we are on number 9. We are going to prove that I can take these two fractions and add them together, and when I do, it's going to equal 2 over cosine squared. So just keep in mind, when you're doing a proof, there's a lot of times where they love to give you fractions. If they give you fractions and they're either added or subtracted, then try to find a common denominator and then try to do that, because it's just a real common thing to see happen in a proof. So anyway, in this case, if we look for a common denominator, it's going to be 1 plus sine times 1 minus sine. So let's go ahead and try doing that. If we're going to make this a common denominator for the first one, we're going to multiply both the numerator and the denominator by 1 minus sine for the first one. And then we're going to multiply 1 plus sine on the numerator and denominator for the second one. When I do that, all I got to do is now distribute 1 times 1 minus sine, still 1 minus sine, and 1 times 1 plus sine is still 1 plus sine. And you can see, I hope, that the negative sign and the positive sign are going to cancel out. And I'm going to go ahead and copy down the denominator. Anyway, when I get done with this, I'm going to have a 2 in the numerator, and then I'm going to have 1 plus sine times 1 minus sine. Now, if you take a look at what we're supposed to end up with, we're supposed to end up with cosine squared, and cosine squared is equal to 1 minus sine squared. So if I go ahead and multiply this together, I'm going to find out that it's a difference of two squares, and just to show you, I'll separate it. 1 times 1 is sine, 1 times negative sine is negative sine, sine times 1 is sine, and then negative sine times sine is negative sine squared. So when those two middle guys cancel out, I end up with 1 minus sine squared, which we know is going to equal cosine squared. And we're good to go. All right, now let's go ahead and solve the question. And I got to tell you, if you screwed this like I did, then don't feel too bad. You see this cosine in the front and this 5 at the end? You got to make sure that we have both those pieces to this problem. I'm going to replace what we proved, but I also have to put the cosine in the front and then make it equal to 5. Well, see, now what's going to happen is that cosine over cosine squared, that's going to reduce to 2 over cosine. Now all I got to do is multiply both sides by cosine to get that out of the denominator. I'm going to have 2 equals 5 times cosine. Now I'm going to get the cosine by itself, so I'm going to divide both sides by 5. Giving me cosine theta is equal to 2 over 5. Well, now once I get that, I can find the inverse to find my one angle. And when I do that, I end up with 66.4 degrees. And see, then the next step is to go over here and do a quick sketch. If it's cosine, I know it's over the x-axis. And so typically all I got to do is subtract 360 minus 66.4. I find my other angle is 293.6. I did a quick look at the range and make sure that I don't add any more 360s or subtract any 360s to find more angles, and that's all I need, and then I'm done. So I hope that helped, and thanks for watching.